Okay guys, today we're going to continue working on the C++ parser, but before I do that, I want to see if I'm live on YouTube. Okay, I am, and I'm almost certain that I'm live on Twitch, because that seems to be a lot more reliable than the YouTube one. Okay, we are. Perfect. I'm getting better at this. I think I will have to switch how I'm doing it in OBS, though, because it is still kind of inconvenient, but for now, I think I have the flow down. I just have to make sure I adjust the settings in the YouTube stream before I start. I think I have to click the go live button, which sort of initializes the stream. That would be my guess of how it works. So maybe there's some way I can add that as a custom doc in OBS. But optimally, I could just have YouTube as my main streaming source and then use all the built-in features for that, which you can't use if you're using Twitch as your main source and you're using the plugin to multi-stream to all the other platforms. But yeah, let me test the chats really quick. Okay, YouTube chat is not working. Awesome. Love to see that. I usually recite the messages anyways, but that will be another short-term goal to accomplish. Yeah, I think I figured out what was happening last time. I think I was just testing it the wrong way. I figured out what was happening with the skipper that I made. I was testing it the wrong way, and also something else I found out was that it is like I have it implemented wrong. I did it wrong, is what I found out. So like for example, if you are trying to parse two equal signs, what's going to happen is the thing's it's gonna parse it, and then it's gonna use the skipper after that, and instead of detecting that there's more characters afterwards and throwing an error, it's going to say, oh, well, it's the same character type, so I'll just keep skipping. So now I have it so that it's only set from, so that it transitions only when it's going from letters to special characters or spaces. And spaces always skip, so that's, I mean, that's always going to be the case there. Oh, wait. The bot joined the YouTube chat, so maybe that'll work now. What about now? Okay. Strange. Oh, okay. I was just lagging, I guess. So yeah, there's going to be one more message after that. Okay, well, yeah, that'll do for now. It seems that the bot is more consistently joining the YouTube chat now, so that's good. Okay, let's get into it. Let's see if we can actually start, adding some more stuff this time instead of encountering errors with the parser implementation. So, have we finished the name? Do we have everything we need for a C++ name? Well, let's open up our yes, I made this thing I'm about to pull up. I personally wrote all of this. The C++ reference. I definitely wrote that. This thing. I'll keep it on the first monitor so you guys can see what I'm actually looking at. Then we'll go to basic concepts, identifiers. Where the hell are they? Here they are. And we basically just have to check and make sure we have everything here. So we do have template names. We do have the literal operator names. We do have conversion functions. Let me just double check that one really quick. Right. That's basically what this is. And the thing I like about this is that it's all, like, contextual within the parser when it comes to, like, the semantic actions. So I could use a declarable identifier in, like, 1,000 different ways if I wanted to, assuming I'm just using it in a different context, and I can attach different semantic actions to it. So I could have identifiers for conversion operators, methods, fields, whatever the context deemed fit. So that's cool. One thing the only concern I have with this approach is that eventually everything's going to turn into like a big long list of just code, but you're going to get that with pretty much any implementation. That's more a matter of organization. So, and this approach actually minimizes that quite a bit. So, I think it's going to be our best bet. Yeah, I want to see if I can just get a good amount done today, implement a lot of features, and then just sort of that way I can get a frame of reference for how long this entire process is going to take. But I also want to make sure what we have right now is working. So I already have the name parser plugged in here, and we're using the C++ skipper now. So let's see what happens, shall we? Oh yeah, apparently the Game Awards is streaming right now, so I mean, I don't know if that's actually going to be good or bad for my stream. Because on one hand, a lot of people could be watching the Game Awards, and on the other hand, more people could be looking at YouTube live streams right now. So I don't know which factor would overcome the other in that case. But yeah, let's test actually all the cases based off of this. So yeah, let me just copy this, see if this works. Cool. Now, we do have some stuff with the, some issues, I should say, with the errors, but they're not actually that big of a deal. It's literally just like the order of the errors. I could probably like parse it through in a way where not like parse it as in text parsing, but I could probably create rules and logical constraints to make sure that well, I can actually walk through what's happening here. So we have the operator overloaded operator name, which is being detected in name. It's actually the first one that's being checked. It's going to check for the keyword operator, and it finds it. So now we're entering a new context. Basically, it's going to look through all these, and since we have no characters, they're all going to error. And this one is also going to error, but declarable identifier actually has semantic actions or semantic terminations when it errors. So it's going to display those, and there's going to be an error. Wait, no, it's going to set those as the error, but there's also an error in the first place. So while it's technically correct, I think the problem is that there's just not enough context for it to make sense, I guess. I mean, I guess it's not correct. It's not working. It's an error, but it is working as we've written it, what I should say. It makes sense what's happening. But yeah, it's going to check this declarable identifier, see that there's no characters, and then it's going to throw this error. And is it throwing the identifiers cannot begin with one as well? No, it's not. But yeah, for example, if I just put like true, well then we're going to get different errors. It's just this error over and over. So I'll have to find some way to filter the errors. Probably like, yeah, I don't know. I could change the parser implementations, or I could just find some sort of smarter way to do it. Kind of like with what I did with the C++ parser, which probably doesn't work fully yet, but it's a smarter approach. It'll save me work. Okay. Yeah, but, I mean, if you have a valid, identifier, it works. So, that's cool. Now this, I don't even know if this is possible. I don't even know if you can have a template type after operator keyword. I don't think it is. I mean, I guess you could have conversion functions, but I'll just have to, I'll have to look into that more. But everything we've tried to account for is working. So like operator plus, operator minus, put it next to the letters, operator minus minus, but if you have 3 minuses, well then you get an error. That is not a valid Operator. I almost forgot the word. Same with like minus, plus, or if you put an A. But spaces are fine, because spaces can be skipped. Yeah, let's just test all the other cases. So we already tested this. Already tested that. If I just copy and paste this, will this work? Yep. I think it's funny how we still have the syntax highlighting from our older implementation. I guess I'll just keep it for now. It's not really hurting anything. Operator new. We have cases for that. Would be like the allocation operator or something. Use as many spaces as you want. Oh yeah, that's a good thing to show actually. So I don't know. Yeah, this is right because minus would be an operator. But there is no operator that only has this as its character, so you can add as many spaces as you want there. Okay. I think this works. Let's see, is there anything else I'm overlooking? I'm assuming the deallocation operator works because the allocation operator worked. Identifier. Identifier should work. So now what we can do is we can use names, this name parser for like declarations and definitions and get like the associated God, I don't even know the terminology well enough. Whatever the name is associated to, and do logic on that. So yeah, cool. Alright, I guess we don't need any of this anymore. Template name, literal operator name, version function name. Nope. Not need any of that. And now we can add this to our construct parser, so that's cool. So comment, well, I don't know if we can do that. I mean, names by themselves aren't going to be constructs. There's going to be, how do I even have it structured? I think it's comments, definitions, declarations, and preprocessor directives, which I haven't added yet, I don't think. Oh, I don't even have it written down here. That's cool. Do I have a, okay, I do have a canvas. So yeah, a directive, a declaration, a definition, or a comment is how I have it structured right now. Those are going to be what goes in construct thing. So, where do we go from here? We could either implement preprocessor directives, definitions, or declarations. Well, we probably want to implement definitions after declarations. Preprocessor directives are going to be deceivingly simple. Or would it be deceivingly not simple? I don't know. Deceivingly complex. Probably deceivingly complex. Whatever we do, it's going to be like kind of a new rabbit hole because everything's, kind of interconnected. C++. Or we could focus on, I guess, more like the base components, like you do like comment or strings. We could do strings. We could do numbers. Although that's kind of boring. That's a little boring. Maybe we should do the boring stuff first, though. So you know what? It's time to get boring. Yes. Yes, it is. I think we should start with strings, because strings are going to be easiest, but I can already tell I'm sort of going to need to break this up into comment areas. I don't know if we're going to need regions yet, but yeah, we're definitely going to need to segment this a little bit. Single line comment. Line comment. Okay. So I'll call this names. Actually, No, I'll try and keep it without regions for now. Right, names. We'll put crap. It's pretty obvious that we're gonna need regions, so might as well do them now. Did we do all caps for this? I don't even remember. What is this? Oh, looks like we want to put this after name, of course. Right. So we should just be able to. Ooh, do we want to make, or we could make more error support? Hmm. Hmm. See, all three of these errors are being used. All three of these semantic actions are being used in this parser. There's got to be a way I can make this more concise. I guess I can make another macro, but the thing with macros is that you start using them and then you find that there's a case where, okay, you need something more robust and then you have to change the whole macro. But, we'll do it. We'll try it. We'll say semantic error message. Or should I do, I think what we've been doing so far is just ERR, so I'll do that to be consistent. And should I automatically prepend it with ERR underscore? I mean, if they're all going to be like that, then yeah, actually, I should. So, ERR, and then, what is it, a double hashtag? I think so. Alright. Wait, this is the wrong one. Cool. That's really cool. Name, message. Let's see what else. Okay. So basically, we're gonna want all this. We'll close it with double close parentheses, semicolon. Exception, double close parentheses, semicolon. I almost did 3 parentheses there. Well. And then we're gonna have the message here. So what that does is it'll basically shrink the implementation down to this. Which is quite an improvement, if you ask me. Now, one thing I don't like about this approach is that we don't know exactly what context is, and we can't really see the full picture unless we hover over this. Maybe I'll add something like that to the IDE that I'm making. If I ever even get to that point. But yeah, that is an annoying part of it. Yeah, we'll just do that manually for the rest of these, because not really a big deal. Okay, this could still be a little more concise. Okay, is it safe to take these away? I don't know. I think we were getting errors from this before, but I'll try it. This one's pretty straightforward. Oh god, what have I done? Identifier cannot be empty. That's awesome. Okay. Alright, let me just see if this one will, compile. Because we might have to add those std string casts back. Which would be suboptimal. But it may not be necessary. Because I think when I had those before, I was testing something else here. Okay. Okay. Cannot add 2 pointers. Yeah, that was the issue I was having. Probably because this counts as a character pointer, not a string. Alright, well. Guess we'll just have to add those back for now. Slightly annoying, but whatever. But I think I added an extra parenthesis there somehow. Okay, let's try this again. I can already see the error here is going to be that, oh my god, did that pick up my gulp? Jesus. I can already see the error here is going to be, or the problem as we scale this is that sometimes we're going to have conditional errors, which are going to require their own logic, so yeah, just a semantic error by itself isn't really going to do too much. Oh crap, how would I do that? Could I use a using? Would using work? It might. It might actually work. I'll have to experiment with that later, though. Okay, declarable identifier. So yeah, that is a lot better. Wow. I did not realize it was taking up that much space. Okay, obviously this one is insane, but there's not much we can do about it. These are just sort of going to be in their own category. Probably put those into separate files at some point. We're still sort of just trying to get this into like a prototype working phase. Okay, let's add strings because I've made those before and they're pretty straightforward. Wait, hold on. So we want to add more errors first. Where can we? Uh, so I don't know if I want to add an error to the actual declarable identifier parser or if I want to add it in specific spots here. It might be objectively better to add it in specific spots because then we could give like more specific feedback. I mean, now that I've already made an operator here, I'm kind of tempted, or a method, I'm kind of tempted to add a method that will just like automatically create errors. Like .e, and then we could have the error code directly in the parser. Or something like that. Okay, so... But also, we're probably going to end up duplicating that if we do the, adding it directly into the parser thing. Or not do that. Because declarable identifier is going to be used on a lot of spots, and I guess here it would just be like invalid identifier, and here would also be invalid identifier, so yeah. We'll put it here. So we'll say rule debug message invalid identifier. And that'll be like worst case scenario. If you don't get any other better support than that or more context, then at least you have this. And also we have all this other contextual stuff already, so. Yeah, wait a minute. Do we really need this if we already have all this other crap surrounding it? Okay, I'm forgetting how this is all laid out. I'm already almost out of gamer beverage. Okay. So I don't think we really need to do anything there. This one's kind of interesting because we could use this for context, and the declarable identifier obviously would have its own error support, and then we could have it be closed with that. And if it's not, we can throw an error that way. So we'll say semantic error, template not closed. Crap. I really wish there was a more concise way to get the current character. I could use using. Wait, no, I couldn't use using there because that would be like a method parameter. Wait, no, I could. Could do that. Pretty sure you can use usings in function definitions, right? I think that's what we've been doing like this entire time when we've included like parts of the sphere.x3 library. Rollout desk thing is very inconsistent with its rollage. Okay. So let's see. Identifier cannot be empty. Or yeah, that's the wrong thing. I'm probably gonna have to end up reworking this whole error system eventually, but for now I don't know. I don't see any precise issues with it. An identifier, or wait, template argument list must be closed with template argument list must be closed with closing angle bracket. And they're called angle brackets. I think last time I called them like arrow or triangle brackets or something, but angle brackets are. Somehow I just remembered that. Also, lame notification sound. Who cares? Do I want to just put. I mean, it's kind of difficult to read that way, but also separating these things. I mean, then they're all going to be kind of hard to read or distinguish. Unless I did something like this. But right now I'm trying to put all the errors before, like, immediately before the parser they're associated with. So yeah, I'll just say .t, template not closed, and that needs to begin with error. Error template not closed. Okay, what else? Name, overloaded operator name, or declarable identifier, template argument list, or identifier. or just identifier. Okay, so no, there's no use putting an error here or here. I don't think. Overloaded operator name, special operator name, allocation operator, deallocation operator, literal operator, variable identifier. Um. Hmm. Might be able to do the rule debug message here. Because if we put, like, terminations in these OR chains, well, then we're just going to be getting a bunch of unnecessary errors. And I don't know if my solution for the whole error thing is going to account for that yet, so I think it might hold off on that. And also, I mean, it just doesn't work. It doesn't make sense with the flow of the parser. Just making sure my mic was on the right setting. And template argument list. Why did I say and? Operator. Thing is, though, if this errors, but then, like, all of them error as well, it's gonna still give this error. I wonder if the solution is to separate the errors by different OR trees, I guess. I don't know how I detect that easily, though. It's the only thing. Could check for the... I'm pretty sure OR serves as an actual parser, so we could check for those if we, like, ascend the parser hierarchy, but I don't even know if there's references to the, like, containing parsers and stuff. Or, like, a... Yeah, I don't think there's, like, a reference tree I could use. So, yeah, how would that work? Maybe after every OR, I could clear the error message or something. Yeah, perhaps. Perhaps. Something like that. Yeah, I think for now, I could probably just say, like for this, overloaded operator name, I could make this a rule debug message. And I think at this point, we're going to need to put this on multiple lines. Error message here. Hmm. We could use the we're also going to need actual expectations here in order for this to work, so we could use this as an expectation. And that way we have this as context to enter into it, so it's cool. Invalid operator name. Just say that for now. Alright, maybe I could just test this now and see if I magically have more context or something. There's a literal operator. Identifier. I mean, we could go a lot more in depth, but at a certain point it kind of becomes redundant because if someone, like... You know, I guess I shouldn't say that. I think I just need a smarter way to detect errors. Actually, if I really want to take it to the next level, the level above Visual Studio Code in terms of syntax error detection. Okay, let's just see what we have so far. And then after this, I think we'll add strings. Then we'll see if we can add numbers after that. We'll go from there. Pretty much, I guess, if we're going to do that, we might as well follow it up with all other literals. All other literal values. which I guess all there is numbers and strings. Unless I am... Oh, I guess there's, would a Boolean be considered a literal value if you just put, like, true? Maybe. But that one would be pretty easy to detect. Hope. Just true or false. Maybe there's some weird syntax feature where it's like, oh, you can put a 0 to represent false if you want, and a 1 to represent true. But even that, I mean... we're gonna... God, I can't even do it because of the mic anymore. This is killing my brand. We're gonna chop through. Okay, we're chopping through. It doesn't... God, it doesn't even work. I don't even know why I'm even trying. We're gonna deal with the errors as they come. Sequentially, one by one. They'll all fall. All the errors will fall. It's an operation. A secret operation. Okay, what parser am I even using right now? Name. Okay, so, yeah, let's try testing this one. So, overloaded operator name. Operator. An identifier cannot be empty. Is it anywhere? Oh, God. What's all this crap? Okay, well, it's right there, but what is this? My God. Yeah, we're gonna definitely need some way to filter through all this nonsense. What if I put like a operator name that's actually invalid, like a backtick? Is that what that's called? Yeah, so it's just giving a bunch of random information. I like how we have this scroller though. Godot made a good choice there, so I don't have to worry about solving that problem now. And then it takes you to the source of the error. That's cool. An identifier cannot be empty. An identifier cannot be empty. Probably because there's two OR chains that are checking for identifiers without any other context. Okay. What's the other error we had? A template argument list, right? Okay. Test. Template argument list must be closed with closing angle bracket. Cool. And the rest of the errors will be done using semantic actions, so to detect things like pre-existing names and stuff like that. Will anything that's runtime, actually, anything that's runtime will be done in semantic actions. I think. Yeah, I don't know how I could do that using this roll debug message thing here, or error handlers is what the underlying system is. This is like a whole thing here. Okay. Yeah, let's actually add the literals. And maybe I can just make this all one big region. I think numbers are going to be the hardest because there's a lot of different ways you can write numbers, but there's also escape sequences that I'm going to have to consider. So we'll see. Pragma end region. Ended right now. Okay. So yeah, I mean, the basic parts of it should be pretty easy, and we can just divide as we go. So string. Can I just use string? This is the parser namespace, so I've explicitly been specifying std string for a reason, right? Okay, implementation. Hopefully this is an error because we haven't implemented anything. Yeah, expect an expression. A surprisingly sensible error for how we have this set up. Okay, so a string. Well, it could either be a multi-line. Wait, no. Strings are either. Do I want to separate characters and strings? Probably. Probably do. So we'll do like actual strings first. So x3 lit. We can use characters for this. We might as well when we have the chance. String lit. Uh, doesn't have to be followed by anything, so I'm going to use the sequence operator. Although it does have to be closed. Yeah, basically what we can do is use the clean and say, how do I do the exclusionary one? I'd have to recheck that. Unless I have a clean somewhere else here. Oh, right. Wait, optional? I don't... Is that optional? 'Cause optional shouldn't, like, destroy the parse if it's detected, right? I don't know. It seems like that's what I'm doing here, though, so it'll probably work. Alright, you can just copy this. Instead of using the asterisk, we'll use quote. And then we'll consume the quote. I think that's how this works. And we'll use an expectation for this. And since this is the only point where we can encounter an error, we can then make this a debug message. I'd have to make a separate parser for string expressions, so things that will account for escape sequences. So yeah, there's that. Yeah, I could do like escape sequence or character. That should work. Alright. Error message will be strings must be closed with I'm gonna do 3 of these in a row. Funny. Wait. Oh god. Oh. Will that even look good? I don't know. I'll just keep it like that for now. And we do need to add a semicolon to the end of this. Okay, let's make a let's detect all escape sequences. And we'll just do a rule for now. Escape sequence. This might have to be like a whole thing. I'm gonna use this documentation. Just to be consistent. I could probably find it if I just search it up. Yeah, it's the first one. Okay. Really? That quote? I mean, I think that'll work. It's just with the optional thing where it breaks out of the clean, it's just like... I mean, if we consume it before going to the optional part, we should be fine. I hope. So yeah, these are all pretty doable. This is where it starts to become more complicated. Which means we're also going to need, wait. The hell? 1 to 3 octal digits. So you don't have to, like, use a letter before it or anything, I guess. You can just, in C++17, you can just type the, number after the backslash. And then this is just backslash X, and then you have all the, numbers. I'm not sure what the difference between these two are. Do you need to have the, brackets here in C++23? I don't know. Additional escape sequences. Hmm. What does this mean? Implementation defined. Conditional escape sequence. Conditional escape sequences are conditionally supported. The character C in each conditional escape sequence is a member of a basic source character set. Basic. Okay, well that's C plus 23. That is not. That is not the character following the backslash in any other escape sequence. So, like, basically anything that's not here can be a conditional escape sequence. I might just ignore that then. Let me look it up though. C++ conditional escape sequence. Yeah, I don't see any. I don't see any more information about it. I'm gonna ignore it. So that's what you do. You face problems. What is this? Unicode. Would this be? Oh God. I forget how numbers work. I'm assuming this would be 8-bit and this would be 16-bit, but I'm not sure. Maybe this is 16-bit and this is 32-bit, or maybe even 32-bit, 64-bit. I don't know. But should be simple enough. And this will also give me an opportunity to learn about numbers. So that'll be cool. I love learning about things all the time. It never ends. Arbitrary Unicode. Okay, we don't have to worry about. Yeah, so I was just looking at that one. Okay. So I should make this. Crap. I should. Also, we're gonna have to check for, like, whatever all this stuff is. Okay. C++ ASCII escape sequence. Let's just see some of the possible implementations. Okay. So backslash A, the same code, except without the zero. I don't know if you have to have the zero or not, but we'll also have to account for these. So yeah. Now we could either try and do that dynamically, or we could just bake it into the character lookup. It really just depends where else it's used. Now, Spirit X3 already has a number parser that might do a lot of this stuff for us, so it could be worth looking at that. But I don't know if it's C++ specific, and therefore would support all the C++ features. Question mark. Trigraphs. I'm not sure. C++ trigraph. This is like a whole new thing too. Oh my god. It's a single character. Is this in C++ by default? It looks like they're defining them here, or maybe they're not. God. Yeah, this might actually be something we have to account for as well. Okay, maybe what I should do is go to C++ strings. Start from there, just see what we're dealing with here. Where's the C++ reference? Here it is. Basic string? Nah, that's not what I want. This. Yeah. C++ reference strings. Strings library. That. Okay. Oh, maybe I should look for literals. String literal. Perfect. This is what we want. Okay, yeah, here it is. This is all the stuff we actually need. Should have started here in the first place. So this is the basic string. God, there's so many cases. What the hell? And these are all since C++11, so we have to add them. We have to do it, guys. Okay. So what I could do is make a character lookup that's optional, and then when it's parsed, just like append that to whatever the string is. But the only issue is, would that change the parsing behavior? What does all this stuff even mean? S character sequence, E character sequence, R character. What the hell? Uh, hmm. Raw string literals. Raw string literals or string literals with a prefix. I'm going to say prefix because that's probably the American way to say it. Containing R. They do not that makes it better or whatever, but American, so they do not escape any character, which means anything between the delimiters that and that becomes part of the string. So it's like super duper. Take this as literally as possible. Literal. As part of the string, the terminating. Well, it looks like you can have characters before it, though, as well. Okay. I can see the utility in this. Can you have multiple in one? Oh, I see. Because it's all inside of here. Yeah, that might. Okay. Oh, this might require us to change the parsing behavior. Uh. Crap. Crap, dude. Okay. But hold on, is it the same thing every time? Concatenation. I don't even know. I don't even know what that is. Unevaluated strings. Wow, that's really cool. Raw. Okay, so this is the only one that's like. Okay, well, what is all this other stuff? L quote concatenation. Okay, what's the one that comes after that? LR quote. Oh, is that like a concatenated uh raw? Concatenated raw. U8. That's probably going to be different. Okay. Oh, there's only one though. U8. What does the U mean? Unsigned? Unsigned 8-bit string. And then there's raw, which is intuitive enough, I suppose. But then you have U. Would that just be unsigned? I guess a string represented by unsigned characters? Then why do you need the 8? They're already characters by default, right? Then there's uppercase U. Whatever that does. I wish it would say. Maybe it does. Maybe I just have it. Okay. Wait, no, it doesn't. Wait, 5. Hold on. I should use the numbers. Use the numbers. But what is it associating them with? God, I don't know. I don't know. 1. Oh, okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Character from the basic character set, except parentheses, backslash, and spaces. Cool. We're gonna need a lot of tables and stuff. Oh, God. We certainly have our work cut out for us. But, I mean, once we finish this, I don't know how much harder the rest of the stuff's gonna be. Maybe once we have literals, we need definitions, declarations, expressions. Yeah. We'll see what we can do. All right, so my determination is that crap. I don't know. I don't know what my freaking determination is. Now, what I'm thinking of is, do I want to have all of these as separate parsers, or do I want to have like have that be behavior elsewhere? I mean, if we're gonna have to specify the behavior either way, we might as well do it in the parser. But then there's also the question of performance. Like, we have less wiggle room with performance when it comes to the parser, because we can't just like use a table and then conditionally branch from that. I don't think. But it probably won't be a huge deal. Although, if we want to check for this, that means we're going to have to check all the other ones before we do. Ooh, okay. No, we can use the context. Duh. The contexts create helpful spots for us to do things. So if we're smart with our context, we'll, should be fine performance-wise. I'm saying that having no idea what the long-term performance impacts are actually going to be. Okay, is there anywhere where it's not necessary to make these parsers? Because what we can do is we could have a lookup table that has all the valid characters here, but then if we have something where it's like, oh, you can use any 32-bit character, well then that becomes a little more, yeah. There's a little more, yeah, basically. Basic S char and escape sequence, a universal character name. Oh, only these can have escape sequences? Interesting. Or, I mean, it's conditional based off of which type of string literal we're in. Okay. So, wait, what? Oh no, this is number 1, and then this is number 2. Basic S character. An escape sequence as defined in escape sequences, a universal character name as defined in escape sequences. Wait, this one, isn't that raw? Am I insane? See what's on more S characters. Oh, we do have the names here as well. Okay. D character sequence. Sequence of one or more characters. Okay, so we happen to be looking at the right one. Wait, no, we weren't. We're looking at this one. Okay, I should just use these names. God, like learning the layout of this website is like learning a whole other language, but I feel like it's worth learning because once it all clicks, it'll be so much easier to navigate and will probably be pretty intuitive or useful, quick, efficient. U8 S character sequence. Okay, so S character sequence. Sequence of one or more S characters. S character. One of a basic S character, an escape sequence as defined in escape sequences, a universal character name as defined in escape sequence. What about the trigraphs? I don't see anything about trigraphs here. So maybe this isn't built in. I'm just going to ignore those. We'll just ignore those. Universal character name, though. That is. All right. Key character. A character from the basic character set, except parentheses, backslash, and spaces. And the S character is a basic S character. R character. Character from the translation character set. Character sets and encodings. Okay. Where's the translation one? Glyph? Oh, right. I think I know what that means. I mean, it's just like the visual representation, the pattern that is being used, the glyph. 26. How are C++ versions named? I thought they were named based on the year they came out. And I don't think the year 2026 has happened yet. And I definitely don't think wait. I don't think C++ has been around since 1926, and I definitely don't think the year 2026 has happened yet. There we go. That's more effective. Basic literal character set. Cool. I know what this means. Bell. It makes a bell sound whenever it's added into a string. Backspace. What the hell? Backspace is a operation, not a character, right? No. Okay, well, obviously, no is, a thing. Maybe this is for, like, explicitly specifying a queued backspace or something. I don't know. Carriage return. I have no idea what a carriage return is. Okay, where's the translation ones, though? Here we go. Unicode. Oh my god. Oh, yeah, so this is going to be the one that's, like, insane, the translation character set. It's probably at least 16-bit. So a table will not work there. Which is why it might make sense. Well, crap, I don't know. That may be a benefit to separating all these into separate parsers, because then for like the ones that are lower bit precision, I can just use a table that has, 255, 254, however many values there are. And that, well, I'm assuming it would use all the values, all 256 values, but yeah, we could definitely put that into a lookup table, whereas something that's like 16-bit, not really. But if we separated them into separate parsers, when we go to the one that's lower bit precision, I can just use a lookup table, be faster. And I can throw an error if it doesn't work, and in the other one, I don't have to. So getting that premature error detection is ideal. Okay. It looks like probably want to put these into separate parsers. Although, if I wanted to, I think what I'm realizing is I could only make 2 different parsers, one for the raw strings and one for the non-raw strings. It's just I'm going to have some runtime logic determining, you know, if it's a certain bit precision or not. What do I want to do? Also, I'm seeing some problems with our skipper that may come up. Although there's actually a solution for that would probably be better than using the sequence operator in the first place, so maybe it's a good thing. I don't know, though. I still don't know the long-term pros and cons of using this new skipper. Okay. Decisions. I love making decisions about things. I feel like part of the hesitation for doing it runtime is because I just don't know what that's going to look like yet. So I actually had a solution that I've already made for runtime. It may sway my decision. Okay, shoot. We're gonna do them all as separate parsers, at least for now. Yep. Okay. Be nice if I could give them... What are the names, though? This is raw. This is, What is the difference between these two? Is this just to specify that it's literal? Could this be the same parser, then? D character sequence. What is a D character? What does the D stand for? Oh. What? How's it storing those if it's, only 8 bits? At most 16 characters long. Character from the basic character set, except parentheses, backslash, and spaces. Character from the translation character set. Okay. We could turn these all into parsers. Maybe that's a good spot to start. Okay, maybe I'll start with the D character, because I could turn that into a table. Parentheses, backslash, and spaces. parentheses, backslash, spaces. Okay, so I guess we just remove those from the table. Okay, yeah, let's start by making a parser for D characters. So that seems like it's going to be the most straightforward one. And we're going to want symbols for this. Yeah. Not symbol skip. And we are definitely going to have to put these tables in another file pretty soon. Maybe Spirit X3 add-ons? I'm not sure. At this point, it's just becoming like a C++ specific Spirit X3 add-ons, but whatever. Alright, these are D characters? Yeah. D character. D character. What are the character parser? It probably just parses any possible character ever. Does Spirit X3 even work with 16-bit characters? Crap, I don't even know. Does Spirit X3 work with 16-bit characters? I think when I was watching a presentation, it said like it didn't support Unicode or something, which might actually be an issue, which hopefully wouldn't like cause exceptions. We could just check it at runtime, but be something we have to work around. Oh god. Okay, it looks like there are at least ways to do it, so not really too concerned about it. Yeah, I think this is the presentation, one of the presentations I watched. C++ Con 2015. TF8 and boost.spirit with 32 parser. It's the other way around. My specific case. Okay, I'm just gonna assume it's not gonna be a huge issue. No, not Google Chrome. What are you doing? Oh my god. Alright, so what we're gonna do, we're gonna make the robot do it. As we do when we're doing things like this. Exclamation mark, quotation mark, number sign. Okay, that should be enough to get us started. Oh, and this will just make character. Although, I mean, I guess they're all gonna be 8-bit. Or maybe not. And that might actually just be incorrect. just because they're in the standard character set, which appears to have less than 256 characters, less or equal, um, then I don't know why they wouldn't do that. Like a nice memory optimization you could make. And this programming language was made in like 1874, so that would be smart of them to do. Okay, let me plug this into ChatGPT. Everyone's favorite threat to the global economy. Okay. Can you alter this C++ pattern to include all characters from the basic character set? I'm going to say C++ 17 because that's always important. Oh god, what is this? You want to include all characters from the base character set in C++. You can modify the pattern to include ranges for each character class. The basic character set includes... Okay, so they just turn this into a giant freaking string. No, I want you to explicitly continue... Why can't I type explicitly? There we go. Continue the pattern I started using the parentheses and repetition entries. No! Oh my god. Okay. ChatGPT is gonna fail me this time. Could look up a character set. Regenerate. I'm gonna try regenerate it a couple times. No. Wait, are they just numbers? 0 to 128. What? Oh, I guess we could. I guess we could do that. But is there only 127 of them? I don't know. What? Oh, 96 characters. Really? Do they just correlate directly to the numbers? Or I feel like that's not true. Yeah, let's try regenerating. What if I say, can you continue the C++ 17 pattern? Oh my god, what are you doing? Stop. What? Basic character set. C++ list of basic characters. Plus 17. God. Oh my god. What is this? It's using console out? Stop doing the wrong thing. How does that even work? What? Could we use a constant expression for this? Could we make a custom parser? They're just based off the numbers. I wish I knew how to understand anything, because there's this code unit thing. I don't even know what this means. Maybe these are hexadecimal. Hmm. Basic character set. The same thing? Okay, yeah, it is. Is that like a C++ reference specific thing? Thank you. I could just like copy these per column, that'd be so much easier. I could send this to ChatGPT and maybe it'll automatically understand it, but I doubt that. I guess it's worth trying. Is this even correct? Okay, we're gonna try it. Okay, it looks like it did copy it well enough. Could you modify the C++ 17 pattern to include all basic characters listed below? No! My god. I want you to continue the pattern of parentheses, not create a new implementation. I was going to say idiot at the end of it, but I won't. That's not continuing the pattern. I want to see parentheses. It's just going to start adding parentheses everywhere. Separated by lines containing only the characters as literals. No! This is the worst I've ever seen ChatGPT perform. I'm embarrassed right now for ChatGPT. Okay, I'm gonna be rude. What part of this pattern do you not understand? Thank you. Oh my god. Thank you. Thank you. See, if you insult the robot, it does what you want. Oh my god. Finally, dude. Probably didn't include the spaces, but I might just enter those in manually. Doesn't even know what I'm trying to do. What is the double backslash there for? Okay, well, whatever. Whatever. Paste it in. I don't like the look of this. Okay, maybe I should actually read, like, what it is. Okay, never mind. It's just an arbitrary set. I don't know what this double backslash is here for. Oh, that must be the, Wait, what is this, though? Oh. Wait, we already have that, though. Right? Oh, no, I just modified that. Oops, the one I modified. And that would be the backslash. Okay. So now we just need, we should need all the spaces up here and stuff. C++ escape sequences. So we want tabulation. C++ character tabulation. It's \T. Is that here? Oh, horizontal tab. They have different names. Okay. That's convenient. Wait, what? Line tabulation? I don't know. Although it does say it right here. Could use the ASCII encoding. But then it's... Oh, no. Wait, what? Yeah, it would be the same thing. C++ use code units in characters. This is like a whole can of worms. Can I do this? Okay, if I get rid of the plus, maybe. Maybe it'll magically work. Oh, God. Incorrectly formed universal character name. Now we can also do the X thing or whatever. Okay. That works. I hope. And it would be 9 based off my understanding of hexadecimal. My very limited understanding of hexadecimal. What is B? I don't know yet. Okay. But we'll just do the same thing. Should be fine. Also, we need the attributes. Okay, we're gonna do this 4 more times, right? I am correct. 000B. Wait, was it uppercase or lowercase? I feel like that's important. I'll do uppercase. But it may not be important. 11. Okay. This is seeming quite hexadecimally. 000C. Got the X's. That's cool. 12. Okay. And then space. I could just put space. Yeah, let's do that. All these other things are going to be kind of hard to read. Like, I mean, a tab, would that even work, doing that? That just gets turned into 4 spaces, it looks like. This might be one of the only ways, like with escape sequences. You might have to do it with escape sequences, is what I mean. Character 9. Oh, you can see the numbers this way. That's really cool and interesting. 126 characters. Is there something I'm not realizing here? Because here it says 96. Let's see if there's anything that doesn't belong. No, I mean, they all look... Oh, it could just be the numbering, I guess. Yeah, that's probably it. I think this should be right. Although there might be a better way to do this, actually. I mean... It'll still be pretty fast since we're using a lookup, but there might be a more memory-efficient way. But, I mean, this just comes down to numbers. ChatGPT was giving me some pretty concise ways to do it functionally. Yeah, this should be fine. Okay, D character. That is a D character. What else? S character, basic S character. What is an S character? I don't know. Oh, basic S character. Character from the translation character set. The translation character set. Wait, since C plus 2023. What the hell? C++ translation character set. Now, I'm assuming when it says translation, it means like translating between languages. A superset of the basic character set. And it's only been since C++ 2023. Basic literal character set. Cool. That is not relevant. Each abstract character assigned a code point in the Unicode. Okay, this is... I'm confused. S character sequence. Okay, maybe if I just assume that that it's not in C++ or 17. It's not in that. Seems kind of strange though. If this is used for converting code, then I think it should be used in all versions, right? Or like compiling or something. Escape sequence. Okay, we already know that's going to be like a thing we have to do. A universal character name, as defined in escape sequences. Okay. Character for the translation character set. Now we here, and it doesn't say any version stuff. Okay, let me look up another website. Maybe it'll be more clarifying. No prefix or all those prefixes. Character literals. They're differently based off their prefix. Character literal without a prefix is an ordinary character literal. Value of an ordinary character literal containing a single character, escape sequence, or universal character name. That can be a single character. It can be represented in the execution character set. Is value equal to the numerical value of its encoding in the execution character set. I don't know. Where have we been getting the D characters from? D character sequence? Is that what the U does? No. I don't understand. Parentheses. Oh, also we do have to get rid of this. Maybe D character is specifically for entering into whatever U8R is, or U1s, or raw strings. Yeah. A sequence of. Now my mic's like not correctly positioned. A character from the basic character set. Okay, so what is our character? Character from the translation character set. Okay. I'm assuming that means any character. Which would mean I don't know if we even have to have a D character parser. Although it's probably I'm gonna keep it just in case, because that's what I said for the keywords, and I had to add them back in. Went to. Okay. What did the the minuses do? Yeah, it may not even be relevant for parsing. Okay. We should have started here. We should have started making these parsers. Okay. Let's just do it. I'm gonna pull it up on my second monitor because that's gonna be faster. Sorry, guys. For you. Let's see. RD character sequence. Okay. 2. It is 2. I don't know what 2. Wait, is it like. Is everything based on section? Raw string literals, initialization, explanation. Okay, I'm gonna ignore the numbers. Completely ignoring them. Wait, what is this? 1, 2. Ordinary string literal. Oh my god. Ordinary literal encoding. UTF-8, UTF-16, UTF-32. I don't know what those mean, but it looks like they're correlating to the numbers. Oh, wait. So the U means UTF. Okay. Alright, we almost have enough information to do this now. Okay, so we'll start with, string Should I say string literal or just string? I'll say string literal. I'm going to specify each literal by appending it with literal, underscore literal. I was trying to say like, oh, prepending. Well, what would be the opposite of prepending? I guess it'd be postpending, but that's not really a word that's used, so yeah, we'll just append it. Prepend, append. Wait. I don't know. I don't know how words work. Whatever. String literal, we'll just make the names for now. Also, at this point, we'll comment it. We'll comment it out. Maybe something there can be useful. String literal, wide string literal. That's what L means. Okay. Wide string literal. 1 and 2. Well, that's raw, so that'd be raw string literal. The second one with the R before it. Right, and then UTF 8. Do we want to do it like that or that? UTF. I'm gonna do it like that. UTF 8. String literal. And then we need 16 and 32. And then we can prepend raw to all of these. Make the raw versions. See, there I had a use for the word prepend. But would append be at the end or just somewhere in it? I don't know. Again, I don't know how freaking words work. Okay. And yeah, it looks like they all have raw versions, so let's get some raw edge going. Or do I want to do that dynamically? Oh my god. You know what? I think a lot of this stuff will become apparent as I just build out the parsers. I'll say like, wait, I'm reusing this a lot, or I don't need to reuse this. And then I'll just be able to, you know? But it's also the question of how we debug it. Crap. Okay. Well, let's just commit for now to the doing everything through the parsers strategy. Okay, raw string literal, raw wide string literal, raw UTF-8, UTF-16, 32, whatever. I can't talk that fast. Okay. So now, copy this. This is going to require some repetition. It's the only thing I'm concerned about. But this one, pretty straightforward. It's the default stringage. Or do I want to do the... well... Let's try this. Yeah, that's probably better. Oh god, this is going to be kind of large. Just make this a normal rule for now. It'll be a normal rule. Okay. Quotation mark. Yeah, so here's what we want to do instead. It's the fastest way I could do this. Ooh, okay. Okay, now I'm thinking it might be better to put it up here. God. All the other ones are going to have some sort of prefix. So, we need this. And I guess just to make like a template I can reuse, I'll just put a backslash there. And then they all end with another quote. So, that'll work. Wait, we don't need the last one to be that, though. The closing one. Alright, so this will be our template for every other one. Cool. And these first parsers right here are going to be the thing that gets checked when we're doing the ORs. And if they fail, it'll just go on to the next one. So, should be relatively performant compared to like having to check this entire freaking thing. And then the next entire freaking thing. Okay. Let me pull up the reference again. Okay, wide string literal. No, this is the wrong spot. We want to do it here, right? Yeah, R. Well, all of these are going to begin with R. Okay, wide string literal, is that the L? That one begins with L. So, L, R. R is always the last one, it seems, so, yeah. UTF-8 will be, U8. Then U8R will be the raw version. And then we have U, and then uppercase U. Alright. Cool. Now we just need to check what comes in between, the best part. And we're also going to need to have escape sequences. Crap. And I just realized we are going to have a use for our D character thing. Just to enforce compiler restrictions. I guess it would just be the general specification. The C++ specification. Okay, well this one is pretty straightforward. It's pretty much any character, I think, because translation set, I'm just going to assume that means any character you want ever. That could be wrong, though. Wide string literal. Okay, wide string literal. What is a wide string? Ordinary string. Wide. Okay. 3, 4. Okay, wide. Wide character. What is wide literal encoding? Ordinary literal encoding, wide literal encoding. Basic literal. That doesn't necessarily mean basic literal encoding, right? What is a wide character? C++ W character T. Characters which require more memory to represent them than a single character. Okay, cool. Whatever. But I think you can have either in a string. So R. Wait, R is gonna be the raw one. So that's what we're gonna have to do here. So let's say, what was it? D character? Yeah, D character minus what is it gonna end with? It's gonna end with this. Then we're gonna expect a opening bracket. And then we can have our actual string, but also our character. Okay, so it can be any character. Cool. So this is basically what we want. So it'll be followed by this. Well, that's optional, so I guess we don't need expectation there. And it's going to be closed by this. And then this will be an expectation to get the closing parentheses. Parenthesis? I don't know. And then close out. Oh, wait. We need one more of these. God. You know, I'm going to use expectation since this is optional. Wait a minute. Yeah, okay. Yeah, we do need one more of these. This is quite the parser indeed. Okay, and then finally, it's going to end with our quote. I'm going to keep it on one line because, why not? I'm getting stupid notifications on my phone. They're very stupid and dumb. So do I want to try and enforce these in some particular way? Well, let me see. If I do string test equals how do you even do this? Can I look at what's in the translation characters? A Unicode character? God. Oh, jeez. Like a whole thing. D3. What? These have like... Okay, that's the pronunciation. BTD chi? Wouldn't that be C? I don't know. Ow? Okay, we're gonna... This is obviously some sort of translation thing, so let's just copy a random character. And if I try to make this explicit... Or actually, if I just use a normal string, what happens if I... Oh my god, it just gets converted to a T. That's funny. Really? No. I refuse this outcome. J. Seriously? Is Unicode not allowed? What is this? Okay, symbols. Let's look at symbols. It's not showing us the actual symbols. This is just gonna get converted. Is this just the font? That's a comma? It must be using, like, modulo or something. Script X. Okay. Unicode character. Copy, paste. Just gonna look that up. Huge list of Unicode character symbols. I want this one. Okay, for some reason that worked. Cool. Okay, so doesn't look like I'm getting any errors. Pretty sure this isn't included in the standard character set. Wait, constant character 3. Is it just making the characters longer? Hold on, if I try to make this character, what happens? This is a whole new can of worms. What is this? Constant character pointer. Okay, what if I change this? That works? Oh, it's an int. Okay. Converting it to net. So it's it must be implicitly converting. So okay, I see. Uh ugh. So is anything, but this is for characters. So this is character literal. So this is different. But I guess these are using either 16-bit or 32-bit integers. By default in C++, ooh, I don't know if they're 16-bit or 32-bit. I want to say 32-bit. That's what they are in C#. Hmm. I think that's what they are in C#. I don't know. I don't know for sure. Okay, well, what if, theoretically, I specify this specifically as, Unicode 8? What does that do? Well, yeah, it just converts to other characters, but I don't know. I don't know how this works. Well, assuming I can just do any character I want, what's the point of any of this? I'd have to check it at runtime or something. Or just let the compiler do it, maybe. Uh, what if I try the raw? U8 raw. Am I not doing it right? U8 raw. Then C++11. What? Parenthesis. Oh, I see. Dang, this is something I haven't seen before in this syntax highlighter, but I never really go this in depth when creating strings. What about that? E. Can you have any amount of optional D characters? Well, I guess it's not a D character, but I wish it would say that. Oh, invalid character in raw string delimiter. Okay, so what we're doing kind of has some validity. All the separate parsers and stuff. Uh, okay. It's pretty much just like what we have is good. As far as like the wide ones and everything, or the Unicode, it seems like it's not being enforced. Like if I do this, it just gets converted to a character sequence with three characters. I'll try this though. YT. That just adds another. Okay. But we know we can put any character we want in there. But the semantic action I feel like we should keep the parsers separate anyways. And I mean, if that one works, then U and or UT, God, UTF 16 and 32 should work too. Wait, what? What is this? No suitable constructor exists to convert from constant character 16T to the basic string. Uppercase U. I guess this would kind of be, these would both be 8-bit, right? Constant character 32 array. Okay. Hmm. Okay, I mean, I see what the issue is. We'd have to use a type that supports an array of character 32s. But this is just checking the conversions. It's not really it wouldn't be specific to the parser. What about wide? Isn't that kind of a similar thing? Yeah, there's still 32 bits when we use L. Wait, what? W. Oh, wide character T. Okay. What other string types are there? Maybe I have to include a library or something, but okay, this seems manageable enough. Okay. Oh my god. Strings must be closed with yeah, I guess they do. But this is kind of outdated now, this specific parser. Wait. What? No, we don't need this either. At least not yet. Okay. So yeah, I think all these parsers should be fine, except for, you know, these 4, because we need to use this one. It's more so the runtime data we have to worry about. Although, I guess I'll keep them as separate parsers for now. And I messed up all the prefixes. That's cool. Okay, we have to copy this a little bit differently. Was I copying the one above every single time? Wow. Such a genius. Okay. So, I don't know. I don't know if it's enforced or not. Like, what's the point of the prefixes if, like, string automatically handles it? I guess, I mean, obviously, explicitly specifying, but is that it? Just explicit specification? Or is there anything more to it? Because when I had U8, it would still let me put Unicode characters. It was converting them to 3 characters. Yeah. Which would mean we could just convert this entire thing into 2 parsers. But we'd still need some way to detect which prefixes were correct. You could have 2 separate symbol things that detect all the valid prefixes. Should we do that? Should we fully commit? I mean, for now we will until we have a reason not to, because this is Terrible. This is awful. Okay, we'll make... And this, crap, should we use the skipper? Can we? Let me try. STD string, wow, equals U space 8. We can't do that. Wait, are we getting an error? Okay. Alright, I'm just gonna do it how it's done here then. So, yeah, we're not gonna use the skipper. Just gonna use symbols. All we want is symbols. Okay, we'll say, ordinary character prefixes. Or string, ordinary string prefixes. Ordinary string prefix. String literal prefix, we'll say. And this one should be way less large than this one. Okay, and instead of character, it's going to be std string. Okay. Can we just use an empty string for one of them? Explicit type is missing. What do you mean? Okay, well, there's L. L. Then there's going to be U8, U, and U. Okay. Thank you for adding 80 billion tabs. That's really helping me. We'll start with U8. So I think we're doing this in the order of bit size. Well, technically the entire thing isn't, but for the U region, yeah, technically that would put L at the bottom and put this probably above U8. What is this though? Oh, I see. It's because we screwed it up, that's why. Yeah, this isn't going to parse anything, so should automatically succeed, right? Crap, I don't know how that would actually work. We'll just continue like this for now. Okay, so ordinary string literal prefix, and then raw string literal prefix. Wait, that's the wrong thing. What's the opposite of raw? Hooked. Hooked string. Hooked string literal prefix. No, I gotta do it by the book. By the books, the 80,000 books that are on the internet about this. There is, I think I actually do have a C++ specification book in my house somewhere, but probably from like 1742 or something like that. It's probably not 17, well, C++ 17. It's probably like C++ negative 40 or something. But either way, the specification's still on the internet, so. Okay. These would all just end with R. LR. Your. Okay, we'll just do the lazy technique and just get rid of the suffix here. Cool. Why is that one still not working? Idiot. I don't know. I don't know. So now, you just be able to do this. Raw, please. Raw string literal prefix. And this one can be... This will actually make it more performant, so that's cool. But again, we're going to have to do more runtime stuff. I will have to prepare myself for that. And then for string, even though this is kind of imperfect naming, but whatever. String literal or raw string literal. Cool. Oh, we do have to make sure that these are followed by open quotes. Cool. Okay. Oh god. It's being overridden. Well, if it's not raw, what is it? I need to know. Raw string literal, okay. It's kind of hard to get around this. Okay, well. Crap. We'll just do this. I mean, the entirety of strings, the entire string parsers in 2 lines, pretty cool. Oh god, I feel like my neck is acting up again. Crap. Okay. Almost there. We just need to test now. We just need to test and see if it works. String literal. Obviously, we don't have escape sequences or anything like that yet, but we're getting there. Oh crap! Maybe that was something I could have done with the other parsers. Okay. There goes all of our work that we did in the last, like, 10 minutes. But whatever. We're going to need these separate so we can specify where we want literals and whatnot. And then we'll just crap. Then we'll just crap. Standard string literal. This is what we'll do. Oh god, even this is going to be kind of large. Oh wow, it's actually going to be very large. Jeez. Okay, we'll separate it into different lines, I guess. And I am going to keep this distinction up here, because I feel like it could be useful. God, this is a lot of ors. I don't even know if I can multi-thread this yet. How I could, like, divvy up the workload. Expected an express. You got an expression. There's your expression. Wait, hold on. Don't need that. Okay. This literally has to work. Okay, thank you. Okay, here we go. Here's our test. Thing that's nice about this approach is that I'm fairly certain at this point, yeah, I could literally just get a for the syntax highlighting, I just attach a semantic action and get the start and end of the iterator and add that as a color region. What the hell? Do they have to be strings? Maybe they do. That's kind of lame. Is that why? Where is it happening in our script? 175. Yeah, that's probably it. Okay, well, whatever. Isn't isn't the single quote itself also a string though? Or a E character? Maybe not. Oh, now we have this, of course. Wait, what? Oh no, they are. They're right there. Okay. Well, can I flip this now? That work? Okay. Why is this not working? Missing closing quote. Oh, you are correct. Also, we're gonna make this a string. We might be able to make the return type of character, but eh. Okay. Do the thing. Compile. Oh, what is this? 318. Cool. Oh my god. How? Why was I not getting errors for that before? Wait, this can be a... Might as well make this a character. It could all be characters. Okay. Place. Triple quote with this. The smarter version. Okay, and I'm assuming this is just gonna work here. Hopefully I'm right. What? Wait. Uh... Okay, that... That might have just been a weird, anomalous error that I occasionally get. I might have to delete a certain file. Okay. Wow. It was taking an interestingly long time. Why does my neck feel screwed up again? I don't know if I told this story, but um basically I was just sitting here in my chair like last weekend and I went to go crack my neck and I felt like I just like ripped my freaking neck off or something. Like I felt like a jolt in one of my tendons. Fortunately it wasn't like an artery or anything like that, which is something that can happen when you crack your neck. Um yeah, it's just been like in pain for the last week. So that's been cool. But it's obviously gotten better. And it was pretty much gone today, so I was stretching my neck a little more. And now it's back in like a new form. But I'm sure it'll heal again. Okay, why did that take so long? Alright, here we go. Alright, what is that? Could that be the air handler? I'm not sure. Whatever. Yeah, that works. We can do U8. Of course, our syntax highlighting is not working, but U8 does not work. U works, L works, UL. What? Oh, I'm getting it confused. I'm gonna do UR, right? What? Oh, this is raw, so it needs to obviously have stuff in it. Okay, cool. So it's working exactly as intended. Do L, U8, 6, or just U, and then uppercase U. Okay, perfect. I'm assuming it works between lines, right? Yes, it does. Okay, cool. We have started string literals. Didn't we do something else earlier in the stream? Yeah, we added some errors and stuff. Okay, well, we're making it through. We're making it through. I'm probably gonna end stream here because I'm quite hungry. Uh, so yeah. Thanks to everyone who stopped in. And I will see you guys in the next one.